What up, Fat Finger Squad? Y'all give me a minute here. Running around like a chicken with his head cut off right now. Give me a second here. Fat Finger Squad in the building. What is going on, y'all? Let's see if GNS3 will play nicely with us. I didn't reboot here. And GNS3 be acting funky if I don't reboot. Today's lab is configuring what was it? OSPF, passive interface manually. What's up, Danny? We got Gonzalo in the building. We got the plant-based brother. Y'all got perfect attendance over there, man. Y'all sitting in the front of the class today, ready to go. I said I was gonna do some labbing over the weekend, and I didn't. Had to attempt to undo my daughter's micro braids. Yes, I don't know if y'all know about black girl hair, but micro braids is like they're braids, but they're really, 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 really small. And she had maybe about 100 of them, and I think I only undid like 3, and it took me all day to do those. And I was like, I can't do this, man. So I brought her back to mom, and she said, all right, I'll just bring her back before school starts. So I brought her back Sunday. We said configuring OSPF passive interface manually, right? Is that the exact wording? Because remember I said I got the old book and the new book. In case you guys are following along for the first time, this is the lab guide we use, 101 Labs, Cisco CCNA version 4. You can get a copy of this from 101labs.net. It's authored by Paul Browning and co-authored by Farai Tafa. Experts agree that we retain only 10% of what we read, but 90% of what we do. That is why I love this book. And I say that every stream, don't I? Also, if this is your first time tuning into this live stream, that's my tag for y'all. Let's see. We just need to drag and drop 2 routers. Let's try to knock this out quick. All right. Let's get the version 15 one today. No, let's go with this one. Let's go with this one because we don't have any other switches that's gonna be messing us up today. Plus, I wanted to play with some serial interfaces. Looks like we got router 1 and router 2. We'll just cable them back to back. If you are using packet tracer, that's fine. If you are using even G, that's also fine. You're probably a little bit more fancy schmancy like my man plant-based brother over there. Rest in peace to my fingers. What you mean? What happened? What did I do with my fingers? Oh, yes. When I was unbraiding her hair. Man, I had a rat tail comb and everything. I was really trying hard, man. And I think I only got like 8 of them done. And I got to say, she has to have at least... I didn't even count, man, but it had to have been at least 70 braids in her hair, man. And I really, really, really tried, man. Took a break during the day. We're going to back-to-back serial interfaces. Serial 2 to serial 2. Going to give it a little time for some late stragglers to come in. This should be a real easy one. We shall knock this out. This is the same topology as the last lab. We're going to be configuring the router right. We're going to configure the... We're going to configure the interfaces with the IP addressing, which we've done multiple times, right? By now, y'all should know how to configure an IP address, but if not, that's cool too. We'll still do it. I'll also, what are we going to do? Enable OSPF, and then we're going to configure the passive interface. If you know anything about passive interface, basically we don't there may be some interfaces that we might not want to broadcast our OSPF networks. It could be for security reasons. It could be like maybe let's say we had like 30 interfaces on a router, but one of them we don't want an OSPF being broadcasted out of, but it falls into a network in one of the network statements. So what we would do is not change the IP address. We would just make it a passive interface, so that way OSPF is not talking out of that interface. There's only one interface for each of these routers here, so it's it wouldn't really demonstrate that very well on here. But let's go ahead and label these bad boys, right? So we just got 02, 02. What else we got going on here? Let's put some IP addressing here. What we're gonna do here? Boom, boom. This guy is 172 dots. What network is this? This is the 172.16.1.1/26. The other guy's gonna be 1.2/26. All right, so we'll duplicate that bad boy. I've been really thinking about even G, man. I'm in the contemplating stage, as Danielle would tell me. I'm in the contemplating stage. So I've been looking at the software. I think I thought I had installed it on here. No, I tried to I checked last time, didn't I? Nope, I didn't. So thought I had it on here. Thinking about at least downloading it, maybe setting it up. These two routers are going to sit in OSPF area 0, right? Y'all remember what OSPF 0 is, right? What is that known as? Remember, we always start off the network with OSPF area 0. Let's go with purple today. We'll go with purple, apply, and load that bad boy. We said he is going to be in OSPF area 0. Lab number 50. It's page number 217 in the book. What's going on, Jay Coley? I haven't seen you in a while. You've been absent a couple streams today. I had to tell the dean that you wasn't showing up. Said you was playing Fortnite over there. You said you finally decided to study with us, man. Not the backstage. What am I thinking? This is known as the backbone area. Area 0 is known as the backbone area, right? So this is the area we always start off when you're designing an OSPF network, right? And I think that's pretty much it. This side is going to be doing the clocking. So, and I think I finally, well, I don't want to say I completely understood the clocking, but basically the service provider is going to do the clocking. We just kind of learn about it because we're labbing here. So if you have, your ISP, they're going to be doing the clocking for you. So if this is the ISP, right? Well, actually, this would be the ISP because we're going to have router 1 do the clocking for him, and this would be the customer premise equipment. He's going to be receiving the clocking from router 1, which we'll do on this lab as well. So power these bad boys on. Console in the router 1, console in the router 2, and the objective of this lab is for us to learn and understand how to manually configure the OSPF passive interface. And again, it is remember, we could have, so when we're enabling or configuring OSPF, we have what's called network statements, right? Any interface that falls into those networks will be advertising OSPF out of it, right? Or it'll participate in OSPF. But there may be some interfaces that we might not want to have OSPF participating in it, or we might not want to broadcast some OSPF routes out of it, right? So we would put it as a passive interface, and that's what we're going to do here. There goes router 1. So they are powering up. Anybody have any questions, or anybody else has anything to add that I might have missed or whatever? Remember, this is a safe learning space. No such thing as a dumb question. What I had today at work. Today we got a request. Well, we didn't get this request today, but today we were doing the survey. So they want to expand the Wi-Fi coverage in the back lot of the facility of the place I work at, right? And guess where the back lot covers? It's like this foresty area in the rear of this organization, right? Yes, a foresty like area, just like wooded area, right? So they do a lot of like, I don't want to give too much information, but basically they want Wi-Fi coverage out there. So we had to basically do a survey in the damn woods. Basically, I'm jumping fences. I got these little stickers in my thing, man. So we had to go out there with our phones. We're gonna go out there again because we got to be out there with an actual spectrum analyzer, figure out where some dead spots are and stuff like that. And then we have some access points that are towards the end of the building. We're gonna try to move some forward and then put some new ones up there. So I just was like, man, sitting here jumping the fence. I'm like, my boss, he's cool with it. He's jumping up, but me looked like, me jumping the fence at this job, and they looking at me. It just looked funny. So I was kind of weary about it, but I was like, well, I'm with him. So plus I got my badge on. So, but I know I did look sketchy jumping the fences and stuff like that, looking in the forest with my cell phone, trying to figure out where the dead spots are and stuff. Ready for takeoff, right? All right, so we got router 1 powered on. We only got like, 5 tasks here. And we should knock this out quickly. Configure the host names, which that's already router 1. That's already probably router 2. So task 1 is already done. Right, we got S-Smooth in the building. Oh, that's what's up, man. Well, let me know. If you want to link up or whatever. I usually work Monday to Friday, 8 to 5 and stuff like that. So let me know what's up, man. If you're on the Discord server, you know, DM me or whatever. Let's see here. So we already got task 1. Just the host names and stuff like that. You know what? The book said router 1 and router 3. I got router 1 and router 2, but it is what it is. If y'all want me to do that, no, we'll just go router 1 and router 2. I don't know why they made router 1 and router 3 when there's only 2 routers in here. Plus, they made the router ID. They changed the router IDs, which we're going to do that as well from the last lab, right? Task 2, configure router 1 serial 00, which is a DCE to provide clocking of 768 kilobits per second to router 3. So router 1, we're going to set that interface with that IP address, have it set the clocking to router 2. So just like last lab, right? So we'll go to router 1, and we'll go to that serial interface. Remember, your interfaces might be different if you're using Packet Tracer or any other simulator. Or Boston NetSim. I believe you can do your own custom labs on Boston NetSim as well, right? So the IP address for this guy is 172.16.1.1. Subnet mask of /26, which is 255.255.128.192. Right? And we're going to no shut that to bring him up. And then we'll show IP interface serial 2/0. Oops. I did that in the last stream. I'll be like, that must be wired to type that. I don't know. So that's correct, right? We always check our work with show commands. And when you're done, run a show command to verify it again. We'll go back to that interface and do the clocking, right? Serial 2/0. We said clock rate. They said the clock rate was supposed to be 768 kilobits per second. So we did this. This was the same as the last lab. So I don't need to do any conversion here. We'll just do 768,000 like that. And it should change it so it rounds it to that. Remember? So it rounds it to the nearest bit rate that this clock rate that this router supports. So yours might be different. Yeah, so this DM me on the Discord. If you guys want to also join, we have a Discord server where the Fat Finger Squad kind of goes over and talks about any other things that may be Cisco related or route switch related or non-switch related. Like my man S Move, who's apparently in Orlando. Hit me up on there if y'all won't have any other questions. You know, it's kind of like after class kind of thing, you know. So we did the clock rate. Let's just verify what we got so far. Interface serial 2/0. Show run. Let's do that. I wanted to do that. Show run just so I can see what I got so far. We got this restart delay command. Anybody know what that does? I don't even know what that does. I'll look that up. Look that up. Let me Google that and then put that to the side. See, this is what y'all gotta do, little by little. These little commands, like stuff like that, they probably won't test you on this, something like this on the CCNA exam, but it's just little things like that you want to look over at least, and then maybe, or you may or may not remember that stuff, but that's what I do to kind of like remember some of this stuff. So we'll go to router 2 and configure that interface, right? Interface serial 2/0. IP address is 172.16.1.2. Subnet mask is 250, not 252, what am I thinking? I said 192. So it's the same subnet mask as the other one. We're gonna no shut that bad boy. We don't need to do any clocking. We could just verify he is received. I don't know. I tried to do this last time. So what we try to do is see if, so router 1 is gonna provide the clocking, right? He's the DCE side, whereas router 2 is gonna receive the clocking. He's the DTE side, right? I'll give you guys a link on the difference between the two. Where was it? I just had it. Let me reopen. Reopen. I was just looking this up before we started streaming. So if y'all want to know the difference between DCE and DTE, there is yeah, y'all could Google it, but just real quick. I'll give you a second here. All right, so that was the documentation I was looking at earlier, the white paper. So now we did interface. We wanted to verify the clocking and stuff. Show controllers, serial 2/0, received clock rate of this. And it says DCE cable. Now I don't know if this is because it's virtualization. This is really the DTE side. technically, because this is kind of like the service provider providing the clocking to the CPE, or customer provided equipment, or customer premises equipment, whichever you want to say, and he is receiving the clocking. So he is got to receive clock rate, but it should technically say DTE. So I don't know if anybody want to chime in on why it says DCE along with the same side of this cable, right? So let's see here. Show controllers on this side, right? Serial 2/0, not 28. Fuck am I doing? Excuse me, y'all. See, and we did this correctly. This received clock rate, but then yeah, see, this says DCE along with the other side. So, but the clock rate changed, but that didn't. It is what it is. Maybe because, like I said, it's virtualization. You can't. I don't know. You can't really virtualize cabling. I guess, not really, at least. So that was task 2. We did the clocking. We did the IP addressing. Task 3. We only got 5 tasks, and we knocked this out, right? Maybe we'll knock it out as quick as Plant-Based Brother did. Task 3 was to enable OSPF in area 0 between router 1 and router 3, minus router 1 and router 2. Use OSPF process ID 1 for router 1 and process ID 3 for router 3. I'm going to use 1 and 2 for this lab. If y'all want to use 1 and 3, that's fine too, right? The process ID, remember, they're locally significant. They don't need to match. So let's do that real quickly. This is just like the last lab so far. We said router OSPF 1 for this guy. The network statement, we need to put, what we're going to do with the network statement here is to say whatever interface falls in this network, have them participate in OSPF, right? Just like last lab. So I think, matter of fact, the IP addressing might be the same as last lab. Yep, it sure enough is. So in this case, 172.16.1.1.0, right? Because that's the subnet, not the exact IP address we're doing here. We could if you want to. And then the wildcard mask, which is what, 255 minus whatever the subnet mask is, right? In this case, right? So 255 minus 255 is 0, and then 255 minus 255 is 0, 255 minus 255 is 0, and in this case, 255 minus, what was it, 192, which I think was 63, right? Let me do that again. I can't remember. Y'all know I got a short-term memory. 192, my bad. So, no, wait, my bad. What'd I say? 255 minus, was it 192, the subnet mask? Yes, 192. So 255 minus 192 is 63. So my bad. I don't know what I did last time there, but yeah, it's .63. And then notice I press enter. It says incomplete. What am I missing here? You in the back. What am I missing here? Yes, you over there. Anybody put it in the chat? What am I missing right there? It says incomplete command. Why you figuring that out? Let's go to router 2 and put that network statement. Start with that network statement. I'm gonna go to router 2, and his router process ID is going to be 2. We say network 172 dot. That's correct, Danny. And Plant-Based Brother. We're missing the area, and what area is that? Area 0. So we had to put the area there. 16.1.0 subnet. Same thing with the subnet mask, right? But this is the wildcard mask, not the subnet mask, when we working with network statements in OSPF. 000.63, which we got with the calculator, right? Area 0, as Plant-Based Brother and Danny said. Anything else we got to do here? Nope. We press enter. Now let's verify our work so far. Why do we not have an OSPF statement? I mean, neighbor yet? Right? Because we got to put that guy in area 0. They got to be in the same subnet and in the same area for them to participate in OSPF together, or at least become adjacent with each other, right? That's what we call it, right? We have one neighbor, one guy that speaks OSPF. He says, hey, how you doing? Or he says hello, right? Because he sends a hello packet. And then the other one says, hello, my router ID is blah, 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 blah. What's yours? My router ID is blah, blah, blah. You speak OSPF? Yeah, I speak OSPF too. Oh, that's great, man. Here goes some routes. And then the other one says, here goes some routes. They share these routes. They become OSPF neighbors. And it goes from down to init to exchange to xstart, blah, 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 loading to full. And when they're full, that's when they're neighbors. Which in the next lab, speaking of which, we're going to run lab number 51, which is debugging the OSPF adjacency. So we'll see them come up, which we've done already, right? We did it after class. We did a Wireshark capture and saw the hello messages, and then all the way up to till they became OSPF neighbors, right? So now we got to do area 0 for this guy, and then there it goes, right? So now they're neighbors. So I was missing area 0, as plant-based brother Danny said. And let's go to router 2. You notice he got that message as well, right? Says, oh, this is an OSPF message. We got a level 5 message, right? Remember, there's 0 through 7. And 0 is like catastrophic emergency. 7 is like just information. Let you know something. So this is a message 5. Like, hey, look, we got an OSPF neighbor here, right? Let's just know there was an adjacency change, whether it was up or down. Who knows? We got to read the rest of the messages to see what that is. It says we got it in process number 2. Whereas router 1 is what? Process number 1. See, they don't got the match, right? Just remember that. EIGRP, that second number, or not second number, but it's really the ASN. So EIGRP, when we're doing EIGRP, it's going to say router EIGRP, and then this number got a match. But that number is not a process ID in EIGRP. It is called what's the ASN, autonomous system number. But let me not confuse y'all and start talking about that until we get to EIGRP, right? So then it says here, what else we got here? Number 172.16.1.1, where did we, that is his interface. That's where we got it from. And we learned it from 020, which is that interface right there, which is the same thing as him, right? And then we went from loading to full, right? This is just like the last lab. So let me race through this, right? The next, what was the next task? That was task 3. Verify the adjacency as formed, which we did right there. Make a mental note of the router ID. What is our router ID? We didn't check that yet, right? Is our router ID 172.16.1.1? Or is it something else? We could do show IP protocols to verify. Right now I'm in router 2, right? Pro, if I can spell. His router ID is 172.16.1.2. Does anybody remember the election process for the router ID? That's not a pop quiz for today, but it is a quiz. Oh my goodness. Election process for OSPF router ID. While y'all figuring that out, I'm gonna go ahead and change that manually, right? Because just like we did last lab, it says we wanted to use. Okay, so we made a mental note, right? His router ID is 172.16.1.2, whereas router 1, which you probably guessed it, show IP protocols. We'll see we are on OSPF 1, whereas the other guy was OSPF 2, right? And then our router ID is 1.1. That's router, he is router 1, and that's his router ID, which is the same thing as interface, right? Let's, we're almost done here. Task 4, manually configure the router ID. We're going to change him to 1.1.1.1, and then we're going to change him, or router 2, to 2.2.2.2. The book says router 1 and router 3, so they're changing it from quadruple 1 and quadruple 3. I'm just doing 1 and 2. So, anybody got any questions or anything so far? Danny got it correct. If it picks the manually configured router ID, and if that's not configured, it'll choose the loopback. If there's no loopback, the highest loopback address is going to pick the highest interface that is up. So that's correct, Danny. Let's go to router 1 and change his router ID. Y'all remember how to do that, right? Just like the last lab. We haven't done anything different yet, man. This is like Groundhog's Day. Like, am I sure this is a live stream, or is network playing a joke on us? We're going to go back to that process, and we're going to say router ID. We're going to change it to 1.1.1, right? And then we got to reload or clear IP OSPF process for that to take effect, right? Because if we do show IP protocols, we'll see it is still 16.1.1, right? So let's go ahead and do that. We will clear IP OSPF process number 4, right? Could you do that? I'm not 4. 1. Could you do that? Yes, 1. That was wrong. You got to do clear IP OSPF 1 and then process. So there you go. You sure you want to reset that? Boom. It's going to make the OSPF neighbor adjacency bounce. It should at least. Oh, because I clicked no there. See, by default, it's saying if I would have just pressed enter, it said no. So that's like a fail-safe method. That's why they said they left no as default. So I got to do that over again, right? And actually type yes, do that. Now the adjacency bounced, right? So it went down. So it went from full to down, right? That's the initial state, right? First it goes down to init, to exchange, xstart. I don't remember what the other ones are. And I think loading and in full, if I'm not mistaken. Let's pull them up. Let's pull them up because I want to remember them. I want to remember them. OSPF neighbor states. And I put this in the last lab too as well. No, I don't want to do no damn voice search, man. I don't even think this, oh, this does it, man. What am I thinking of? So yes, these are the neighbor states. So down, attempt, init, two-way. I'm gonna pull them up for y'all real quick. Right, down, attempt, init, two-way, exchange, xstart, or xchart, xstart, and exchange, loading, and in full. So what I was missing was the attempt, the two-way, and exchange, xstart, and then loading it in full. So that's what it was. I was missing the attempt part and the two-way. Anyway, I'm thinking out loud. What was we doing? That's the white paper. I'm gonna put it in the group chat for y'all to remember. I know I sent it to y'all a bunch of times, but that's how I do. And that's how I remember them too. So we cleared the router, and now let's verify, show IP protocols, what we done. His router ID is now quad 1. Let's do the same thing on router 2 and change his to quad 2. Y'all with me so far? Router OSPF 2. We're gonna say router ID is 2.2.2.2. Right? And then we gotta bounce the connection again. OSPF IP. What was it? OSPF 4. I mean 2. Why do I keep clicking 4? Process. Are you sure? Yes. Bounce that connection. Show IP protocols to verify. And when you're done, run another show command to verify it again. No, at least 2 show commands for some, right? Notice I've been doing show IP protocols, right? Oh, I did show protocols there. What I meant was show IP protocols, right? And then I verified the router ID from there. How else can I verify it? You know another one? I did show IP protocols and I verified that the router ID is 2.2.2.2.2. We could also do show IP OSPF interface and then serial, and then put in the interface of who is participating in OSPF, or the one you want to look at, which is 2.0 in this case, and we'll see router ID right there. There's another one, right? So there's a couple ways that you could verify the router ID there, right? So try to at least remember 1 or 2 show commands other than just show run, because show run gonna tell you everything, right? Well, I do show run, right? But when you get to like time tests, like CCIE labs and stuff like that, and you actually got to go in there and configure, you ain't got time to be space barring all day to looking through the config and then go through all this and then look up. Oh, there it is right there. Router ID 2.2. You know what I mean? So you want to try to learn some other show commands other than show run. So we did that. That was task number 4, right? So we manually configured the router ID, reset the process on both with the clear IP OSPF. We verified that the adjacency was reestablished. We verified the OSPF neighbor addresses are now showing as the manually configured router IDs on the physical interfaces. Oh, instead of the physical interfaces, and task 5 was to finally what we came to do, because NetworkBruh talks so damn much, was to set the serial interface on router 2 as a passive interface. So we got to go to router 2 and remember what passive interface is, right? Let's say we had 1, 2, 3 interfaces, and they're all participating in OSPF, right? That means we're going to be sharing OSPF or broadcasting OSPF routes out of these interfaces, right? But let's say this one is connected to, I don't know, some network that some Joe Blow, some guy we don't know, somebody network we don't like, right? And we don't want to share our OSPF. For some reason, we don't want to share our OSPF routes with them. So we're going to put that interface as a passive interface. So in this case, they said on router 2, we're going to set this interface as passive interface. But guess what? There's only one interface here that's participating in OSPF. So guess what? That's going to tear down the OSPF relationship. As a matter of fact, I think that's what it said, didn't it? I thought it said that in here somewhere. Thought I seen that. No. Okay. So anyways, let's go ahead and do that. Go to router 2, and I'm in router 1 right now. But yeah, see, that's how we verify. That's another way to verify it, right? Or we could also filter down. If you want to, you use the show command and you just don't remember show IP protocols and show IP interface, blah, blah, blah. You could filter it down to right show run and then section or pipe section and then put OSPF. That filters down to our configs right there, and then we can see. So you could do section, you could do filter, but then if you do filter, include in OSPF, it's gonna only include, right, just the stuff that has the word OSPF in it, right? So section is a good filter command you want to learn as well. What's the bigger difference between OSPF and OSPF 2? I didn't know there was an OSPF 1, but I think what you're trying to ask is what's the difference between OSPF version 2 and OSPF version 3? So OSPF version 2 is the IPv4 version of it, whereas OSPF version 3 is the IPv6 version of it. And you know the difference between IPv4 and IPv6, right? Is that your question? What you wanted to ask, Danny? I don't know, but clarify it, because I think that's what you're trying to ask. The bigger difference between the two. But that's the main difference between the two. So yeah, we want to make that passive interface, right? So global config mode, and go into that process, router OSPF 2 in this case, and I believe you just do passive interface and then you pick the interface. Yep. So passive interface, and then you pick the interface, which in this case is passive interface 2. What we could also do is set it passive interface default, right? So what we would do is let's do it this way first, because that's how they I think they're gonna tell you how to do it. So passive interface, you pick the interface. In this case, it's gonna be interface serial 2/0. Right, so we're gonna make that interface right here. We're gonna say, don't broadcast or don't let that interface participate in OSPF, right? We do that. Theoretically, it should turn it down, and it did. See, process ID 2, number 1.1. Who's that? That's this guy. On serial 2/0, it went from full to down. So now our OSPF neighbor is down or detached, right? Let's go to router 1 and see what happened, right? What does he see? He sees the adjacency was forced to reset. Is he still participating in OSPF though? Let's do show IP OSPF neighbor. He still shows a neighbor though. That's interesting. Let's check over here. So his is down. Let's see this. Let's check this out. We made a passive interface, right? Show IP OSPF neighbor. He don't show a neighbor. Do we need to? Oh, there it is. You got to wait till it's dead. And you remember what the dead timer is, right? No, version 2, like in the exam. Let's check the exam guide. While I pull that up, y'all remember, see, he still showed him as a, so router 1 still showed router 2 as a neighbor. Why? Because we got to wait 4 times the hello timer for us to consider our neighbor dead, right? So router 1 kept saying hello, and he did that 4 times as hello. He says hello every 10 seconds, right? And then 4 times that is 40 seconds. So after the 40th second, he said, okay, he must be either turned off, there's no power over there, or he's just participating. He's just not participating in OSPF. So, but we don't know. All we know is that he's not participating in OSPF. Where really what happened is we made that a passive interface, right? So back to Danny's question. We pretty much wrapped up this lab. I'm just going to answer this question, and we're going to knock it out and call it a night. Tomorrow's lab is debugging OSPF. No, this one's a bit difficult. So I might have to do, yes, debugging OSPF adjacencies. So we're just going to kind of like look at the process of them becoming neighbors and stuff like that. You said on the lab, version 2, like in the exam. So I'm pulling up the exam topics. On the exam, let's do a control F, OSPF, and see what Daniel was trying to ask here. OSPF version 2. So yes, that's basically what we're doing. We're doing OSPF version 2. How can we verify what version we're running? Show IP OSPF. Let's do that. No, that don't tell us which version we're running. But I think that's basically what it is. So OSPF version 2, I don't even think there's a version 1. Is there? I don't even know. You don't really need to know about OSPF version 2, so let's see, because I really don't know. I'm not going to make pretend I do know. OSPF 1 V1 versus 2. Let's see. Because really you don't need to know. So OSPF version 2, see, yeah, just like I said, OSPF version 2 is IPv4's OSPF version, whereas OSPF version 3 is the IPv6 version. So now here's a really older one from the Cisco Community Lab Guide, or Cisco Community Guide Lab Guide. He's been looking for the difference between version 1 and version 2. Let's hear. ISPF version 1 is so old that nobody even remembers about it. That's why I didn't even bring that up, bro. So you don't even worry about version 1. And it's not supported by anybody if it ever was. And this guy's a Hall of Fame master. He is a pretty knowledgeable and reputable contributor to the Cisco Learning Network. So don't even worry about that. All you need to know is that OSPF version 2 is what we use today, and that's what we use with IPv version 4 versus OSPF version 3. That's used with IPv6. So just like I said at the beginning. Does that make any sense? So yeah, that's pretty much it, man. If you guys aren't joined or on the Discord server, go ahead and join that. If y'all want to talk some more, S-Move, hit me up, man. Maybe we can link up or whatever. Let me see what else we got going on. Yeah, so we halfway through this book. I just realized this is lab number 50. But then again, we're not there quite there, because this book says 101 labs, right? So halfway would be 51, 52, right? But there's actually like 10 more or like 15 more bonus labs, and then and there's actually like 108 labs. So it's like 108 labs plus like 15 challenge labs. So it's pretty much, I ain't gonna say false advertisement, because there's more labs for us to do, right? So there's probably like, I guess you can call this the 120 labs book. But anyways, if you guys want to follow along next time, if there's anybody new, 101 Labs Cisco CCNA version 4. It's you can get a copy of this from 101labs.net. It's authored by Paul Browning and Farai Tafa. Y'all know I love this book because it gives us something to follow and stuff like that. Plus, gives me stuff to kind of like go over some basic stuff here, man. For now, comment, like, subscribe to the network.